Memory management and memory itself is one of the many unsung heroes of computing in the modern day. Without the advent of memory management as we see it today, we would not have many of the luxuries in our software that we have come to expect. Rust is one of the many languages that is seeking for innovation and making strides in ways that other programming languages have never done before. It is important in computing to keep our minds open and be always pursuing new and interesting ideas, and Rust is just one of the many ways that we have done that. I have done a lot of research on Rust and have used it in the past, and as I have done this research and gained this experience, I have joined the masses of people who use Rust that are singing its praises. First, I will explain basic memory management. Then I will explain how data management works in some programming languages, and then last I will explain how memory management works in Rust. First thing to understand is that this black box represents our computer's memory. We can put data in there and we can take it out and we can look at it and we can change it. That's all important concepts. One problem though is depending on how much memory you have, depending on how much data you have, it can become very slow to look through all of this memory. We have 16, 32, 124 gigabyte systems and much more when it comes to like enterprise server systems. Just iterating through and looking at all the data in our systems would be very slow and not efficient in any way, shape, or form. So the way that we have handled that is with something called references or pointers. So this is essentially, this says username. I don't think you can read it. I thought it would look better. But essentially it says, hey, inside of your memory, at the address that I state is stored username. And so instead of looking through all of your memory, you can say, this is username, this is where the username is stored, and that's how you manage your memory. This, of course, can cause a lot of problems and errors, and the way that is handled is very dependent on the programming languages you use. One such way that this is handled is in the programming language C. In C, it allows complete developer freedom, and the way that you are able to create pointers, delete pointers, and everything in between. The problem, though, is that we are humans. We are infallible. We are not infallible, and we oftentimes will create things that are not memory safe and can cause bugs and crashes. This is not good on enterprise scale software and can cause a lot of problems. Another way that this is commonly handled is in a garbage collected language. In more high level modern languages like Python and JavaScript, we see a garbage collector which essentially abstracts the whole process of memory management and says, you don't have to worry about any of this. All you have to do is program, and the memory will be managed in the background. The problem that arises with this approach to it is that you give up a lot of opportunity for optimization. We have these two major camps. We have direct memory management and we have garbage collection. And Rust is offering a third alternative. In Rust, we have the borrow checker system. The way that the borrow checker system works, we have to understand a few things before we can talk about that. The first thing is scope. What scope is essentially the point in your program, the point in your code where you are currently iterating on. And depending on what point in the code you are in a different scope. You have a scope for your whole program, and then you have a scope for a minuscule little function of your program. And what Rust does is says, hey, each of these scopes has ownership of the data inside of it. And once you leave that scope, once you leave the function, and once you leave the kind of higher level functions, that memory is deallocated and deleted. Or not technically deleted, but it doesn't matter. So that is the way that Rust handles it. But Rust also allows you to handle and manage your pointers and references manually. It allows you to mark them as mutable and immutable. And what this does is it allows you to be completely memory safe, but still having the freedom and technicality of a non-garbage collected language like C. And it's important to notice how Rust provides a good cross-section between perfectly programmer handled and completely compiler handled or interpreter handled. The information that was used for each of those was the documentation for each of those programming languages. For Rust, I used the Rust documentation website. There is no listed author or date because they're constantly updated. Similar to the C, where I use the devteams.io documentation, it is open source and is constantly updated, so there's no listed date or author. The Python documentation for their garbage collector was written by Pablo Salgado, and there is no listed date. Now that we understand the differences between all these approaches to memory, I hope you understand the basics of memory management and how, moving forward, we can see memory start to take shape. I implore all of you to go give Rust a chance. It is an interesting programming language that is at the core of innovation and is being seen as a marker for, has been seen as a successful in the future language. I will see you. Goodbye.